Welcome to part 2 of the Sociology of AI. In part 1, we built the theoretical scaffolding, what sociology is, what makes it distinctive, and the two core frameworks, AI as socially produced and sustained, and AI as a socio-technical system embedded in institutions and power relations. In part 2, we turn from theory to evidence. 3 interconnected research clusters guide this 10-minute lecture. Cluster A traces the historical development of sociological AI research, drawing on the view to map 5 major shifts over several decades. Cluster B examines how algorithms function socially, how they produce knowledge, derive authority, create opacity, and are resisted in organizational practice. Cluster C documents how AI intensifies existing social inequalities, particularly along lines of race and gender. A summary section at the end synthesizes the key findings and positions us to consider their implications for interdisciplinary AI research in part 3 of this module. This roadmap introduces the 3 clusters covered in part 2. Cluster A provides historical grounding. View's literature survey traces 5 major shifts in how AI has been studied sociologically, showing that current concerns are continuations of long-standing intellectual traditions. This matters because it prevents the common mistake of treating AI as entirely unprecedented and prevents learners from thinking that entirely new conceptual frameworks are needed from scratch. Cluster B examines algorithms as social objects, asking not what they do technically, but what they do politically and institutionally. Key contributions from Amore, Beer, Borel, and Kristen show that algorithmic power is real but mediated, constructed, and contested. Cluster C turns to the most politically urgent findings, how AI intensifies existing social inequalities. Benjamin, Noble, and Joyce and colleagues show that algorithmic harm is not accidental but structural, built into data, classification systems, and institutional arrangements. The 3 clusters are ordered logically: historical context first, then mechanisms, then consequences. The View's literature survey provides an invaluable historical map of sociological AI research. Reading it helps learners understand why the field looks the way it does today, what debates have been settled, which are ongoing, and which questions are genuinely new versus continuations of older concerns. Each of the 5 shifts View identifies represents not a replacement of earlier concerns, but an expansion. Each new wave of research applies existing sociological insights to new empirical domains. The overarching point that AI is always studied as socially embedded holds constant across all 5 shifts. The sociology of scientific knowledge tradition, which gave us Wolgar's foundational work on AI as socially produced and socially constituting, covered in part 1, has been complemented by empirical studies of how AI reshapes employment, displaces workers, and restructures labor markets. Both moments treat AI as socially embedded. Earlier researchers who showed that AI reflects developers' assumptions have been succeeded by scholars who trace those assumptions into algorithmic bias, discrimination in public services, unfair search results, and the power of digital platforms. Both stress that AI is never neutral. Early philosophical debates about whether machines can truly act or understand have been complemented by concrete empirical studies of facial recognition, emotion detection, automated weapons, and surveillance systems that make decisions affecting people's freedom and safety. Early work examined power struggles over authority and resources within AI as a scientific field. Contemporary work traces AI's power through finance, governance, surveillance, and the platform economy. The concern with power is constant. The domain has expanded from science to society at large. Finally, scholars like Turkle were already exploring AI's cultural effects on identity, relationships, and social life. Contemporary cultural AI research extends this to digital politics, mobility, robot culture, and the narratives shaping public understanding of AI. The key takeaway is that the five shifts are expansions, not replacements. The same core questions about social construction, power, inequality, and culture recur in each wave, applied to new empirical domains. We now turn to the mechanisms of algorithmic power. This cluster is guided by four key texts by Amore, Beer, Borel, and Kristen. Together, they answer the question, what do algorithms do socially and politically? The short answer is much more than technical AI discourse suggests. They produce knowledge in social categories. They derive authority from cultural associations rather than purely from technical performance. They create multiple forms of opacity that cannot be resolved by technical fixes alone, and their effects are systematically mediated by human resistance and organizational culture. Each has significant implications for how we design, govern, and study AI. Amore and Beer together establish the foundational claims of Cluster B. Amore's core argument in cloud ethics is that algorithms are constitutive, not merely descriptive. This is a fundamental philosophical point. When a border security algorithm assigns a risk score to a traveler, it is not reading off an objective characteristic that pre-exists the algorithm. It is producing a social category, high risk, that then has real consequences for that person's mobility and freedom. Amore calls this the algorithmic life of attributes. Data points about individuals are combined, weighted, and transformed into new attributions that may have nothing to do with actual behavior. The second crucial point from Amore is about uncertainty. Algorithms generate probabilistic outputs, not certainties. Yet they are routinely treated as authoritative by institutions. This creates a profound accountability gap. If a hiring algorithm screens someone out based on probabilistic inference, who is responsible? Who can that person appeal to? How can the decision be explained? These are not technical questions. They are political and legal ones that require political and legal answers. Beer compliments Amore by asking where algorithmic authority comes from. His answer is striking, not primarily from technical performance, but from cultural associations. Algorithms are trusted because they are culturally coded as objective, precise, neutral, and efficient. These are social constructions. They can and should be critically examined. Beer also argues that algorithmic power is relational. It does not reside in the algorithm itself, but emerges through the institutional contexts that make algorithmic outputs consequential. This means that the power of a credit scoring algorithm depends not just on its technical properties, but on the banking regulations, contractual obligations, and social practices that make its scores binding. Borel and Kristen add two further dimensions to our understanding of algorithms in practice. Borel's contribution is to disaggregate opacity, the difficulty of understanding how algorithms work, into three analytically distinct types. This is important because different types of opacity require different responses. Type 1, intentional secrecy, is primarily a legal and political problem. Corporations treat algorithms as proprietary trade secrets and require regulation to compel transparency, such as the EU's AI Act, transparency requirements, or the US Algorithmic Accountability Act proposals. Type 2, specialist knowledge, is primarily an educational and communicative problem. Even well-meaning transparency is useless if the people most affected and the policymakers responsible for governance lack the technical literacy to interpret what they are being shown. This calls for algorithmic literacy education at scale. Type 3, the human-machine mismatch, is the most philosophically challenging. Machine learning systems learn statistical patterns from data in ways that do not correspond to human reasoning or interpretation. The system itself cannot explain why it produced a specific output in terms that make sense to humans. Even the engineers who built it may be unable to do so. This is not a failure of documentation or communication. It is a fundamental structural feature of current machine learning approaches. It has profound implications for accountability. If no one can explain why an algorithm denied someone housing or flagged them as high risk, how can that decision be appealed or corrected? Kristen makes an equally important empirical point. There is often a large gap between what algorithms are designed to do and what workers actually do with them in practice. In her ethnographic fieldwork in journalism and criminal justice, she found that professionals frequently develop buffering strategies to limit algorithmic influence. The three strategies are foot dragging, gaming, and open critique. This finding complicates both techno-optimism and technological determinism. Algorithms are powerful, but their effects are always mediated by professional identity, organizational culture, and the meanings workers attach to the tools. The implication is that we must study algorithms as part of institutions and work routines, not in isolation from the people who use them. The third cluster is the most politically urgent section of part 2. Benjamin, Noble, and Joyce and colleagues all show, through different methods and in different empirical domains, that AI systems do not neutrally process information about a level social world. They process information about a deeply unequal social world, and their outputs systematically reproduce and intensify that inequality. What is especially important is that this happens not through malicious intent, but through the ordinary workings of data collection, classification, and institutional design, which is precisely why sociological analysis, rather than just technical auditing, is essential. Understanding why AI produces unequal outcomes requires understanding the historical and structural conditions that shape the systems producing those outcomes. Rula Benjamin's Race After Technology is one of the most important books in the sociology of AI. The quote, New Jim Code, is a deliberate historical reference. Just as Jim Crow laws formally claimed race neutrality while systematically advantaging white Americans and disadvantaging Black Americans, contemporary AI systems claim objectivity while encoding and perpetuating racial hierarchy. The reference is not rhetorical. It makes a specific analytical claim about continuity between historical and contemporary forms of racial domination. Benjamin identifies two complementary mechanisms that are particularly powerful as an analytical framework. First, hypervisibility and punishment. Technologies make marginalized groups highly visible in punitive contexts. Black people are disproportionately subject to facial recognition surveillance, predictive policing algorithms, and automated criminal risk scoring. The well-documented Compass recidivism algorithm, which ProPublica found in 2016 to assign significantly higher risk scores to Black defendants than white defendants with similar records, while also being less accurate in both directions, is the canonical case study. Second, invisibility in care and access. The same groups are systematically made invisible in contexts where resources, care, and opportunities are allocated. Medical AI systems trained predominantly on data from white patients perform worse for patients of color. Natural language processing systems trained on English language text perform poorly for speakers of other language. Recruitment algorithms trained on historical hiring data reproduce the historical exclusions that shaped that data. Benjamin's key argument is that these are not accidents, glitches, or unfortunate side effects. They are the predictable, structural outcome of building technological systems on top of unequal social structures without acknowledging or addressing that inequality. This is why she insists that AI must be analyzed through race, power, and institutional history, not through the language of innovation, disruption, or even ethics alone. The implications are practical. Fixing algorithmic racism requires changing the social conditions that produce racist data and racist institutions, not just adjusting model parameters. Noble's algorithms of oppression focuses on search engines, the infrastructure through which most people access information as a site of racial and gender domination. Her starting point is empirical. She documents that searches about Black women and girls historically surfaced racist and sexist associations, directly challenging the widespread assumption that search engines are objective windows onto the web. But Noble's argument goes beyond documenting bias in results. She situates search engine harm within the political economy of the information ecosystem. Google is not a public utility, it is an advertising platform whose rankings are structured by commercial logic, not public interest. This means the problem is not simply biased data that can be corrected with cleaner inputs. It is the deeper organization of the information ecosystem under corporate control. One way to read Noble's contribution is as an infrastructural account of racism. Racism in search is not a glitch or an unfortunate byproduct of otherwise neutral systems. It is reproduced through the ranking, classifying, and monetizing mechanisms that make commercial search viable. Correcting it therefore requires structural change, regulatory intervention, algorithmic accountability, and potentially alternative, less commercially driven information infrastructures, not merely algorithmic adjustments. Joyce et al. Synthesized these insights across multiple domains, showing that AI can intensify inequalities in healthcare, policing, labor, migration, and other institutional settings. Joyce and Cruz extend this sociological agenda by emphasizing AI as a socio-technical system and calling for research on inequalities, power, and data justice. Joyce et al. Add two crucial methodological and normative points. First, data are always subjective. Every data set involves decisions about what to collect, how to label, and whose perspectives to include. These are moral and political decisions, not technical ones. They are connected to race, class, and gender. Acknowledging this is the first step towards building more just systems. Second, they mount a sustained critique of mainstream AI ethics discourse. Approaches centered on individual bias metrics, fairness scores, and transparency requirements are necessary but sociologically insufficient. They treat inequality as a technical problem, a biased model, rather than a structural one. The historical and institutional conditions that produced the bias and continue to reproduce it. Fixing the model without addressing those conditions is at best a partial solution, and at worst a form of legitimation that gives the impression of fairness while leaving the underlying structure intact. What is needed is not just better AI, but better institutions. We now draw together the findings from all three research clusters. The goal is not merely to list conclusions, but to show how they form a coherent sociological picture, one with direct implications for how AI systems are understood, built, and governed. These 5 findings collectively define what Part 2's evidence tells us, and together they constitute a sociological account of AI that is fundamentally different from technical or purely ethical accounts. First, AI research has a history. Liu's 5 shifts show that current sociological concerns about AI are grounded in longer intellectual traditions. Learners who understand this history are better equipped to identify which arguments are genuinely new and which are variations on established debates. Second, algorithms produce knowledge in social categories. Amore and Beer together establish that algorithms are not neutral information processes. They are participants in producing social reality. This frame reframes the fundamental question of what algorithms do, shifting attention from technical outputs to social consequences. Finding 3. Opacity is structural. Burrell's 3-type framework is practically important. Different types of opacity require different responses. Legal transparency mandates, algorithmic literacy education, and fundamental design reform are not interchangeable. They address different problems. Fourth, power is mediated. Kristen's ethnographic findings are a crucial corrective to both optimism and determinism. Algorithmic power is real, but it is always mediated by the people and institutions that use it. This has implications for research methods. Studying algorithms in isolation from their users and organizational contexts will always produce an incomplete picture. Fifth, inequality is by design. Benjamin, Noble, and Joyce all show that algorithmic inequalities are not glitches that can be fixed by adjusting model parameters. They are structural outcomes of building systems on top of unequal social structures. This has profound implications for what genuine fairness would require, not just better models, but different institutions, different data practices, and different governance arrangements. To learn more about the research presented here, please consult these sources.